expression 10, we've got again two statements equal to each other. We're going to change our base because I can see this is 9 and this is 27. So we can change the 9 to be 3 squared and the 27 to be 3 cubed. Using our power rules, this becomes 3 to the 4x equals 3 to the 3 minus 3x. Same base, we can equate our powers. Becomes 7x equals 3, x equals 3 over 7. So this first one, we need to express log base 3 in terms of x. So we've got two statements subtracting, and so we can divide them. So it would be log base 3 of x over x minus 5 equals log base 3 of a, which obviously means that a is x over x minus 5. We're going to hence or otherwise solve that equation. So if I know that I can rewrite this expression as log base 3 of x over x minus 5, that's equal to 1. I know that 3 to the power 1 equals x over x minus 5. Solving, we bring our denominator to the left, so that's 3 lots of x minus 5 equals x. 3x minus 15 equals x. 2x equals 15. X equals 15 over 2. Number 12. So what we need to do is to try and find a way of getting the value of 15 from the numbers 3 and 5. Hopefully you're all happy that 15 is 3 times 5, so we've got log base c of 3 plus log base c of 5, and so that would be p plus q. For 25, I don't need to worry about the 3, I can just say it's 5 squared, so it will be log base c of 5 squared. Many of you are forgetting that the powers come in front, so this would become 2 log base c of 5, which is 2q. Okay, part B, we need to find the value of d. So from log statement to power statement, we would have d to the power 1/2 equals 6. If something to the power of half is 6, then we know that d on its own is going to be 6 squared, because a half is the same as square rooting, and to do the opposite square rooting, we square. So it's d equals 36. So population of bacteria is growing at a rate of 2.3% per minute. How long will it take to double? So we know that it doesn't matter what our starting amount is. Let's call our starting amount P, and we're going to multiply that by 1.023, and that has a power of n or t, whichever you prefer. And we're trying to find out when that's equal to 2p. We're waiting for the population to double. So we've got 1.023 to the power n equals 2p over p. They cancel. So it's just equal to 2. So because we're trying to find our power, we take logs of both sides. You can take natural logs or log base 10. I'm going to take log base 10. And our power comes in front, so it's n log 1.023 equals log 2. So n equals log 2 divided by log 1.023. Let's find out what that is. So log 2 divided by log 1.023. So we've got log 2 divided by log 1.023 equals, and we're always rounding to 3 sig fig, so 30.48. Obviously, 3 significant figures, this would be 30.5 minutes. Now, the mark scheme specifically says to give to the, the question says to give to the nearest minute, which in my mind this would be 31 minutes. Unfortunately, the mark scheme specifically says not to round, not to accept the answer of 31 minutes. Not 100% sure why that is. Could be something that they then change at a later date, but I've marked it according to the mark scheme. So number 14, Michelle invested 1,500 francs at an annual rate of 5.25%. To find the value of her investment after 3 years. So this would be 1,500 times by 1.0525 power 3. So 1,500 times by 1.0525 to the power 3. So it's 1748.87. 1748.87. 1748.87. To the nearest franc, though, would be 1749. How many complete years will it take for her investment to double? So double it, I'm going to do this working down here. To double would mean her investment is now worth $3,000. So we have 1.0525, so n equals 3,000 over 1,500, which is equal to 2. So we take logs of both sides. Bring our power in front and move the log across. I'm actually going to do that in the same step. And we're going to work out what this is. Log 2 divided by log 1.0525. Gives us 13.54. So it's complete years, so therefore it would be 14 years before it's actually at that level. What should the interest be if it were to double? So we've got 1,500 times by r to the power n equals 3,000. Oh, I apologize, n in this case is 10. So we've got r to the power 10 equals 3,000 over 1,500. So r to the power 10 equals 2. We would then take the 10th root of 2. So r is the 10th root of 2. So we go to math. We need a different root, so we want number 5. 10th root of 2 is therefore 1.07177. R equals 1.07177. Now notice I've got several digits here because the rate of interest is given by these values here. Remember, the 1 point is coming from the fact that we were increasing the value. So the rate is actually going to be 7.18%.